So we'll start. So today's experiment is based. Today's experiment is based on comparative analysis of BJT and MOS transistor rival circuits for LED. So whatever doubts you have, you can ask me in this session. So anybody has any doubts today about this experiment? Yes.
Actually, we were being shown a different experiment on the dashboard, and today only we have got the VJT one. Earlier, we were
Uh,
being shown
Sorry, I didn't get you. Pardon?
earlier we were being shown the comparator experiment on dashboard for week 5, and today only we have got this VJT and MOSFET. So we
Oh,
have tried it by mistake. That was being shown earlier.
okay. I think this comparator experiment is from digital part, right?
Yes, yes, ma'am.
Okay, okay,
Yes, ma'am.
okay. So just today only it is shared with you people.
Yes, ma'am.
Okay, okay. Then I don't think anybody has tried that. Then maybe I'll give it a brief, give the brief of the experiment, and then we can discuss that. I will just check with Victoria if Victoria is present. I just check with Victoria whether it can be discussed in the next tutorial live session on it. So better I can give you a brief if you want of the experiment of what how it should be done. So just a second. Any other doubts other than that? Anything you want to know? If you have little bit gone through the experiment, how to do it.
Ma'am, in the PDF, part 2 diagram is not fully available.
PDF part two. This one, no, that figure two.
Yes, ma'am.
So you can see the screen, right? I have shared my screen. Is it visible in my screen? My screen is visible to you.
Yes, ma'am. Here it's visible, but in dashboard it's not being shown
Uh,
like this. It is half cut. The diagrams.
okay. Then I have to. We'll just confirm with from. Just a second. Just give me a second.
And figure 2 is half visible, not fully visible.
Okay. Okay. I'll just check from Victoria. Hello. Yeah. Can you please can anybody share a screenshot of the uh, that figure in the chat box? so that it is visible to us. Okay, it's a problem.
Yes, Debashrita, what is the issue?
Yeah, Victoria, see in the chat box you can see the figure two of in the PDF that has been shared to the students are not properly given. Can you?
For which PDF?
I think you have send the document of the experiment, right? In their
Yes.
so that in that the figure two is not properly visible for them. They are saying.
Okay.
I will share my screen. Uh, can you access the chat box?
Yes, I can.
So, are you able to see the screenshots that the students have sent?
Yes.
Yeah,
So
yeah,
this one, right?
yeah, yeah.
Okay,
This
fine.
is
I
this.
will check and I will change it also in that.
Yeah, yeah. That will be because otherwise they won't be able to connect. No, that's why.
Okay,
No?
fine, fine. I will change it.
Yeah,
I will change it. Yeah.
yeah. And one more thing, Victoria, that this document, I think they are saying that it has been shared to them today morning. I think only today.
Yes,
So
yes.
they
It has been shared today only. So they will
mm,
be having a deadline on Friday only.
this Friday. So they are saying that they won't be able to ask doubts because they have not yet conducted the experiment. So that is what they are
Okay.
saying. So what should we do about that?
Okay, then we can extend the deadline. They can ask the doubts in the next week,
Next
Monday.
week, yeah, yeah, that will be good.
And then week 6 also has been released, so they can parallelly try both
Hmm.
experiment we can discuss it on next week Monday, so that the deadline will be next week Wednesday for both
Yeah,
experiment.
yeah, yeah, that will be good, better. Yeah.
Yeah,
So I'll give a brief of the today's experiment so that they can understand, and
yeah,
then
yeah, sure.
and any other technical doubts if they have, then I'll just resolve. Okay.
Yeah, sure, sure. Yeah,
Yeah. Okay. Thank you.
yeah, thank you.
So I think this problem has been solved. So I will share my document so that you can see, and I'll give you a brief about how the experiment should be done. Just a second. So this experiment is, first of all, it aims to understand the behavior of nonlinear components in electronics, that BJT, MOSFET, transistors, different types of transistors. So mainly we have only tried to will aim only BJT and MOSFET, that is metal oxide semiconductor transistors. So the first part is and to understand the input output characteristics of the transistor, that is basically a transistor characterization experiment. So first of all, you should refer figure 1 to do that. Here, first of all, you have to keep a constant voltage VCE, that you will get that voltage from the transistor data sheet. So can anyone please tell me what is a transistor uh, that has been model number that has been shared to you, or please inform me. uh, or you can use that transistor number, model number, and find the data sheet in the and in the you can google it by yourself. Uh, then also, if you find any difficulty, please let us know. We'll just try to find the data sheet and give it to you. Uh, so first of all, you have to choose an appropriate fixed voltage value for VBE or VGS in case of BJT and in case of MOS transistor, and then measure and record the IB, that is the current flowing, that is a base current that is flowing through RB for that fixed VBE or VGS. In case of MOS transistor, also you have to find the current, but there will not be any current flowing, so that is another thing. But uh, then you have to change the VC value that from your ADLM kit and the Pixel Pulse, that will Pixel Pulse software that will be using the change, vary the value of VCC from 0 to 5 volt, and measure the voltage across collector and emitter, and also the current across the collector terminal, that is IC, that is the current flowing through RC. So that value, that you have to measure those values from varying the voltages from VC to varying the VC voltage from 0 to 5 volt, and plot those values both for BJT and MOS transistor. Next experiment is that is a part 2, is to understand the behavior of the BJT driver circuit, and to drive a LED, and analyze its performance, and find out how the LED brightness changes, and record those voltages when the LED is on and off. That is, for that you have to refer figure 2. Connect the components as given, that is RC equals to 200 ohm and RB equals to 5 kilo ohm. Apply 5 volt DC here across the potential, and adjust its variable voltage terminal to the lowest voltage output. That means you have to decrease the voltage terminal at its lowest when the voltage output is 0. Then gradually change the potentiometer value, and accordingly the voltage output of the potentiometer will also increase, and observe the change in the brightness of the LED. So first of all, the LED will be off. At that condition, find that the voltage, record and measure and record the voltages across the LED, and also the base current, that is I, you have to measure. Now when suddenly at a point, when you increase the output voltage of the potentiometer, the IB will increase, and accordingly gradually the LED will turn on. At that conditions also, you have to measure both the voltage across the LED and also the IB, the voltage, the base current. Now you can remove RB at that condition, and also check how much is the voltage across the variable terminal of the voltage at the variable terminal of the potentiometer. That will give you an idea of how the change in IB will also change the IC, and also how the brightness changes of the brightness of the LED changes when you vary the potentiometer values. Same thing you have to repeat for MOS transistor. Here, one thing is replace the BJT with a MOS transistor. Now adjust the resistor values is necessary to accommodate the MOS transistor requirements. RB may not be required. That you have to address this point and explain that why RB is not required in case of when you are using a MOS transistor. But the importance of RB in case of using a BGT, that also you have to indicate and refer that point, that why, what is the need for that one, why is it not required, RP is not required if we are using MOS transistor. And also based on the experience of the experiment that you are doing, try to give draw conclusions about how the BJT works, and how maybe talk about the efficiency and the different considerations that you have to do while using these two transistors. Why MOS is what are the advantages of MOS over BJT, or what are the advantages of BJT over the MOS. That all points you have to tell that and inform us in the video that you will be making. Next, the part 4 is, for that you have to refer this figure 3, LDR signal driving the LED. It is as simple as the previous one. Only thing is that you are attaching an LDR here, and depending on the light incident on the at, light intensity incident on the LDR, that is LDR, that is the current, that is IB, base current will change, and accordingly the brightness of the LED will also change. Note the voltages across the LDR and the current through the LED when the LDR is exposed to light and kept in darkness. So that is the point 3 is means you have to note the voltages across when the LDR is exposed to light. You have to note the voltage across the LDR and current across the LED, that is IC, you have to measure. When the same thing, you have to do the same thing for when the LDR is not exposed to light, that is it is kept in darkness. How the LED brightness changes, that also you have to explain clearly in the video. That's it. This is all about the experiment that you have to do. If you have any doubt, you can ask me. Anybody has any doubt?
Ma'am,
Yeah.
this experiment is not visible in my dashboard, means in my code section. In my code section, only visual week 5 and week 6, and in the both weeks are different PDF and videos.
This experiment is not video visible to
Yeah,
you
yeah.
in your
In week 5,
dashboard. In your
yeah,
dashboard, right?
in my course section. Yeah.
Okay. Maybe right now, I don't know whether Victoria is fixing that issue of that PDF or not. Maybe if you are not able to access that, you can
Yeah.
always
Can you please
contact.
uh,
Yes.
share this PDF link in chat box?
Yeah, I can share this, I think, in the chat box. Okay,
Okay.
fine, fine. That
Yeah.
will be
Okay.
most convenient for you guys, right? Yeah,
Yeah,
I'll
yeah.
just share that. Okay.
Thank you, ma'am.
Yeah, thank you. Yeah, I think I've shared this in the chat box. Please let me know if everybody can access that. This you can download it and access that PDF. Please confirm.
Yeah, ma'am. This is accessible, and I download also.
Download and you open the PDF and see
Yeah.
whether everything is correct or not.
Okay. Everything correct, ma'am.
Okay, okay, fine. Great. So, whoever, I request everyone to maybe you can download this PDF that I have shared in the chat box, so that if at all if you face any problem while in your dashboard, you can access this PDF. Yeah. And other than that, if anybody has any doubt, please let me know.
Ma'am, can you show that LDR circuit once?
Okay, okay. Just a second. Yes. Yeah.
Ma'am, in this LDR, we have to use VGT or MOSFET.
Both. See, both all the experiments in LDR also, both you have to do. BJT and MOSFET. Just for the sake of this figure, they have given only BJT symbol. But in that, in all the experiments, in part one also you have to do for uh, part one. This also you have to do BJT and MOSFET both. Part two also you have to do BJT and MOSFET. Part 3, that is the LDR, also BJT and MOSFET both. And try to give analyze those transistors and see what are the advantages of MOSFET over BJT, or what in which cases BJT performs well, that you can mention in your video, and that will give you a good impression, and also you will have a better understanding of the transistors working also. Any other doubt?
Ma'am, how is this LDR working? Like if I expose it to light, so is that the
Huh.
current will flow through it and not flow through RB? So that is why in
No,
BJT,
no,
like
no, no, no. So no. It is a light dependent resistor, right? So if it is exposed to light, the resistance changes. Okay, maybe I think when it's exposed to light, the resistance is low, and when it is exposed to darkness, the resistance is high, and accordingly the voltage drop will change here, right? Current will flow anyway.
no. So like if
Here
the resist,
when depending on the intensity of light, the resistance variation will happen, and as a result the current will change the IB will change. Okay.
like if the current is flowing through LDR because resistance is low, so it will not flow through RB, or it will flow rest through
No, no,
RB.
no,
So
no,
that
no, no.
is why.
It will flow. It will flow through RB, right? The voltage here, it will there will be a voltage drop, and also there will be a current. Here also there will be a voltage drop. So current will flow anyway, but the value of current will change depending on the value of the variable resistance, that is the LDR. That LDR will act as a variable resistance, because that will change depending on the intensity of light. But the current will anyway flow. The value of the
Ma'am,
current will change. Okay.
so if I am exposing LDR to light, how is that LED will not glow? Like what will cause that change?
See, I can explain it. See, I'll give you a brief, but you also go through properly. Okay. When the voltage drop is high, when the resistance is high, so accordingly the voltage drop will be high, right? So that will here Vs, it is connected to potentiometer and the LDR. So when the voltage drop, the resistance is high, the voltage drop will be high, and accordingly IB will be high, and that the IB will also affect the IC, right? IC is dependent on IB, right? So
Yes.
so that so that in that way, the brightness, if high IC is there, the LED will brightness will be more, right?
Yes.
Okay. So any other doubt? Any more doubts you have? Anybody? maybe we'll wait for 2 more minutes and then we'll wrap up.
Ma'am, please explain
Uh,
part two.
yeah, yeah.
Part two. Here it
Part
is given
part
part two.
two.
That is
Uh, j-
BJT driver circuit.
you are not audible to me properly.
Ma'am, BJT driver circuit, ma'am. Part two.
Part two. Okay.
Yes, yes. Here what happens, please.
Yeah. Yes. What is your question?
Ma'am, please explain, ma'am. We have to connect the components as per the diagram, ma'am.
Yes, you have to do
After that,
the
we apply 5 volt across the potential.
this Vs should be 5 volt and the potentiometer that is connected across the potentiometer. Okay, so you will vary the potential or reduce the potentiometer such that the output across here it is zero. This voltage RB and the ground, okay, is zero.
Initially, we kept
Now
it.
initially keep it zero. Output voltage of the potentiometer you have to
Then,
initially keep it zero. Then
then what?
then
Here,
increase.
zero means what happens, ma'am? Here,
So there will be no current.
V equal to zero. Am I right, ma'am?
What?
Here, keeping the output voltage of the potentiometer zero means keeping
See,
VBE equal to zero.
yeah, exactly.
So
So
unless and until it becomes, I think more than 0.7 volt, ma'am. What?
yes. So
The
there is a
transistor will not turn
on.
on.
Yeah.
Okay.
So and then you increase the voltage output of the potentiometer, and gradually that IV will also increase, right?
Okay.
Base
Yes.
current. So
Mhm. Yes.
accordingly, when then after a point, the when IV increase, then IC also increase. Then after a point, suddenly the LED will start lighting up. That is, it will go to on condition. So you have to, at that on condition, and when there it is not on, off condition.
In off condition,
Both.
IB will flow, ma'am.
What?
In off condition, IB will not flow, ma'am.
IV will
Unless
not flow. No, no,
in
no, no. There is a threshold, right? After that only the on will happen. But before that also IV will flow, right? In the lower
because no, I
values.
because the transistor will be off now, ma'am. So how IB will flow, ma'am? Unless the transistor turns on, so it is not getting any path for the IB, na, ma'am.
See, measure and record the voltages across the collector emitter of the BJT for both off and on conditions. Note the voltage across the LED for both cases. There will be a threshold, okay. After that, the transistor will not be on, but that IB will flow, right? Accordingly, depending on this. In the off condition also, IB will very small amount it will flow. Not, but that also you have to note it down. But once the LED goes to on condition, there will be some value. That also you have to note it down. Okay. Any more doubts? in your dashboard it is updated. The document is updated. Please confirm that whether you can access that document in your dashboard or not. The document of the experiment is already updated in your dashboard as informed by Victoria. Please
Ma'am,
confirm me with
ma'am, the diagram is still half cut.
still half cut.
I think it's showing, ma'am, showing to me.
Uh, yeah. Yes,
I think it's
what
showing.
it is
Figure two,
coming.
no?
Figure two,
Yes.
yeah.
Uh, Figure two is given. I am sharing a screenshot. Okay.
Okay, okay.
Yes, ma'am, it's visible.
Okay, it is visible, right? Okay. So for everyone, it is visible, right? It's, anybody please confirm? So great. Then the PDF is showing properly. Then if nobody has any doubts, so you can leave the chat. The PDF is showing, right, Dhruv?
Yes, ma'am, it's visible.
Okay, okay. So if you don't have any doubts, anybody, then you can leave the meeting. If nobody has any doubt, you can leave the meeting.
Okay, ma'am. Thank you, ma'am.